Hello, Algebra 1. Today we're going to be talking about vertical motion models. Many real-life situations follow a parabolic path or the path of a quadratic, like any object that is dropped or thrown. So we are going to use these two formulas today to help us with any situation in which something is vertically dropped or thrown. Okay, in both of these equations, h refers to our end height, t refers to our time, v refers to our velocity, which will be positive if we are throwing something up and negative if we are throwing something down. And finally, S refers to our starting height or the starting height of the object. And you can read all of that information right here. All right, so the first thing we want to figure out is whether this is a throw or a drop problem. Sometimes you are going to be given that information very immediately. So for example, number 1, you dive off a 15-foot diving board with an initial upward velocity of 3 feet per second. How long will it take for you to hit the water? Well, notice that they give you a velocity here. And so this means that we are going to use the equation that has velocity, which is our throw equation. So S stands for our starting height. We are diving off of a 15-foot board, so that's going to be 15. H is our ending height. Well, we hit the water, so we're going to say that that's at 0. And my velocity is an upward 3 feet per second, so that's a positive 3. And now I'm going to go ahead and I'm just going to write my equation. So it's H equals, so I'll have a 0 equals negative 16t squared plus my velocity is 3. Don't forget your t, plus your starting height is 15. All right, and now we're just going to go ahead to our calculator and we're going to graph that. So you'll go to your y equals, put your 0 in y1, and we'll type in the rest of it in y2. Make sure you use x, that's x squared plus 3x plus 15. And now we're just going to go ahead and graph. Okay. So this does create a parabola here, and depending on your teacher, they might make you find both intersection points or just one. I'm just going to go ahead and find one right now. So our time is where we're hitting the x-axis, and time cannot be negative. So I'm just going to go ahead and find this intersection point on the right. Second trace 5, move my cursor over. So this is something we have done pretty recently, and then enter, enter, enter. And this is at 1.07 comma 0. And that means that it takes t equals 1.07 seconds. Okay. All right, let's try another one. Ronald McDonald drops a flower pot from his window at a height of 250 feet. How long until it hits the ground? So again, S stands for our starting height. This is up at 250 feet. H stands for end height. We are hitting the ground, so that's a 0. And they don't mention any velocity here, so I'm just going to cross that off. And that means we're going to use our drop equation. H equals negative 16t squared plus S. So my H is 0 equals negative 16t squared plus my S is 250. All right, and again, I'm just going to go ahead and I'm going to keep my 0. And this was negative 16 x squared plus 250. And graph. All right. So now I know this doesn't look like a parabola, but it really is one. So when you go ahead and sketch it, you should make this look like a parabola. And it's going to make it look like this. And again, time can only be positive, so I'm just going to find the intersection point that is on the right side. All right, so then we're going to go ahead and we're going to do second trace 5, move your cursor over, and enter, enter, enter. And you should get about a 3.95. So 3.95 comma 0. And t equals 3.95 seconds. All right. Let's try another one. Here are your equations again. While at baseball practice, Joe throws a ball up into the air. The starting height of the ball is 4 feet. Okay, so S is 4. The ball travels at 20 feet per second. All right, that's our velocity, and it says it's going up, so that's a positive. And Tom catches the ball at a height of 5 feet on its way back down. All right, so that means 5 is our end height. Since we are given velocity here, we're going to go ahead and use our throw equation. They also use the word throws in this problem. So h equals, notice it's 5 equals this time, negative 16t squared plus, our velocity is 20, okay, plus 20t plus my starting height is 4. Now, if you want, you can move that 5 over, subtract your 5 over, and then you'd be looking at where you're hitting the x-axis, but it's also okay to go ahead and just type in a 5 here. All right, so I'm going to go ahead and do that. Make sure you don't lose this x right here. And notice when I do that, that means my intersection is going to be up here at 5. Now, it looks like both of these are positive intersection points, but it does say that Tom is catching the ball on its way back down. So notice here the ball is going up and then it's coming back down. So I do want this one right over here. So second trace 5, enter, enter, enter. And that's going to be about a 1.20 seconds. All right, I'm just going to draw this picture real quick. Again, we're not hitting the x-axis this time because it was being caught up at 5. So that's a 1.20, and again, it's at 5. So that's 1.20 seconds. If Tom misses the ball, how long before the ball hits the ground? Okay, well, if he doesn't catch it, that means it's hitting the ground and our end height will be a 0. So we're just going to go back to our y equals. We're going to change our end height to 0. And you'll notice now when you graph, we are hitting the x-axis here. And we're just going to find this intersection point right here. Second trace 5, move your cursor over, enter, enter, enter. And that's going to be about a 1.43 seconds. All right. Okay, I see a fountain, so I pull out a penny, out of my pocket and throw it down into the fountain. If I threw it at a downward velocity of 20 feet per second from a height of 5.5 feet, how long would it take to reach the bottom? All right, so we're throwing it from a height of 5.5. That's going to be our starting height. Our end height, we're going to say the bottom is 0. And your velocity, be careful, you're throwing it downward, so this is going to be negative 20. Okay. All right, so again, we're going to use our throw equation. That's the one that has the v in it. So h equals 0 equals negative 16t squared. And it's plus vt, but our velocity is a negative, so make sure you have a minus 20t plus our starting height. All right, and again, you're just going to go. Our 0 is already good right there. This is minus 20x. Make sure you have that x plus 5.5. All right, and again, time can only be positive, so I'm just interested in that right intersection point, but it's possible that your teacher may want you to find both. All right, this is going to be about 0.23. So I'm just going to draw this picture. And it was 0.23, 0. All right, last one. Chris is at a Bulls game. Benny the Bull is shooting t-shirts into the crowd with a t-shirt slingshot. If Benny is standing on a 10-foot high platform and is shooting the t-shirts at a velocity of 30 feet per second, will Chris be able to catch the t-shirt if he is 40 feet up in the stands? How do you know? All right, so an equation's been given to us. Let's go ahead and graph it. Now, something to keep in mind here, there we go. Chris is all the way up at 40. So we are going to have to be careful and make sure that we change our window so that we can see this whole situation. So just like we have changed windows in the past, we're going to go to our window here, and my y max I want to make bigger than the biggest number in my problem, which in this case is a 40. And so I'm going to make this a 50. So this is Chris up here, and this is the path of the t-shirt. All right, and what do we think? Do we think Chris is going to catch the t-shirt? The answer is going to be a no. All right, and we can tell because the parabola does not reach the line. All right, so Chris is not going to get the t-shirt. It's very sad for him. Okay. All right, so there you go. That is your first day of vertical motion model. Please let me know if you have any questions. Bye-bye.